I'd like to show you a lab that I was able to get to operate today fairly easily, and it relates the volume of oxygen gas formed to what the molecular weight of oxygen is. And the materials used are fairly simple and straightforward. Sodium iodide is a catalyst. The key thing, though, is 3% hydrogen peroxide, easily available at the local drugstore. Okay, 3% hydrogen peroxide, H2O2. The importance of the soap is that it allows a foam to be created when the reaction occurs and the oxygen is liberated. It's a closed cell foam so that none of the oxygen escapes. So it's a very elegant, simple way to gauge what the volume is of the final foam, and therefore calculate the number of moles of oxygen consumed and created. Now, the catalyst is not part of the final reaction. Every 2 moles of hydrogen peroxide produces 1 mole of oxygen. That'll be important in the calculations at the end. Now, this part of the video is sped up to 2x using iMovie in the interest of time, but the whole experiment takes about a minute and a half to occur, which is practical in a lab setting. And again, the calculation will be derived from the fact that you begin considering 3% hydrogen peroxide, knowing the molecular weight of the H2O2. You have to determine how many moles I added when I added 20 milliliters, and it's 0.0176. So that number of moles times 22.4 indicates how much volume of foam is produced, and mathematically you get 200 milliliters or 0.2 liters, and it turns out that's what we see in the flask. So I was very pleased to see that occur. And it would be a way to measure the atomic weight of oxygen if you did not know it and started by measuring the foam volume and then back calculated what the weight of oxygen would have to be. Hence the name for the video. Again, here's the math. And the unexpected surprise was how well the soap works in terms of sealing the expansion of the foam so that the numbers are meaningful. Thanks for listening.